Thank you guys for coming. This is celebrating AutoPkg with a new runner. Good morning. I'm starting to lose my voice today, so I am going to try and keep it down a little bit. My hope was to be like super energetic and, that, as Adam put it, developers kind of energy today. I don't have that in my voice. So I'm going to kind of hope that you guys can help with that today, because I just can't. For those of you who don't know me, I'm Scott Blake. I've been in IT for about 20 years. I've been doing Apple stuff since about 2011. It's been a long time. We walked uphill both ways at that point, in the snow, just to deploy computers. And we used to converse on a listserv. Does anybody remember that Mac Enterprise listserv, other than these two that I'm talking about? It does still exist, and it's hosted by Penn State. An archive of all of the messages that have ever been sent are still available on that, which is incredible. They go all the way back to 2004. But again, that makes me feel super old, even more so. Nowadays, you can find me on pretty much anything, Slack, LinkedIn, GitHub. I use @mscottblake for almost everything professionally, so I'm pretty easy to find. I uploaded a copy of these slides up to my GitHub. So if you want to follow along, all I ask is that you don't crash the Wi-Fi, because I might need it later. So one of the great things about this conference is that there's automatic community notes that are generated. There's a link to that in the PSU Mac 206 channel. So if you want to take notes, that's great. It helps the whole community. If you aren't great at it, don't stress over that either. Somebody else might be. I'll put this up at the end if you didn't get it, though, so don't worry about that. So in this talk, as that title implies, we're going to go through a little bit of the history of AutoPkg, and then we're going to celebrate some of those big milestones that it's had and some of the noteworthy tools that have been released over that time. And then we'll talk about a new tool that I wrote that I think is pretty awesome. We'll get to see it in action and then talk about what's next for that. So since there's 3 or 4 different AutoPkg related sessions this week, and I feel like I'm kicking off a little mini conference track, I wanted to kind of take some time and tell us how we got here. So there's going to be a lot of name dropping, a lot of people that are listed here. For each of you that I name, I have lifesavers up here because you guys have saved my butt countless times. I've got Smarties too because you guys are pretty smart people. So anybody, what's that? No nerds. No nerds. No dum-dums either, sorry. But I guess I would ask, if I say your name, raise your hand, stand up, take a bow, something. I might know who most of you guys are as somebody who's been doing this for a long time, but I guarantee not everybody in this room does, except for maybe one. So I guess let's just get into it. We'll skip that one. So our first stop down memory lane starts in 2010, which is a whole 15 years ago. And that's where we find the first code that will eventually become AutoPkg. This was written by Per Olofsson. At that time, it was a project that he called Mac AutoPkg. This code is still available on the Google Code Archive. And if I'm not mistaken, there's a high possibility that some of that code is still in existence today and still being used largely unchanged. That is huge. That's lasted that long. I'm going to skip ahead to 2013. This is where that first 0.1 release of AutoPkg came out. At this point, obviously, the project was starting to get some attention. It was a little rough around the edges, and it was missing a lot of today's features. But that core concept was the same. Same as it is today, and that got a lot of people excited, obviously, since it's still being used. I started myself playing with it shortly after this. I was working in higher ed, so probably October, November after the semester rush finished up. I remember thinking it was absolutely phenomenal. It was great. But at the time, I didn't really have a need for it, so I kind of shelved it. I was managing about 70 Macs, and they were only changing in the summer. So, it was a cool tool, but, eh. I was preparing to use it for that next image that would happen in that summer, but I ended up getting a new job in it before then. I will come back to that, because that's actually getting a little ahead of myself. In July 2014, the Lindy Group released AutoPkg with an R. I feel like this is kind of where the AutoPkg project really gained a whole lot of steam. AutoPkg provided a GUI that helped make it more accessible, especially to those that were non-technical. It made an easy interface to schedule recipe runs as well, which really further simplified that adoption, especially to those people that didn't do Mac every day and didn't know how to do launch daemons. This is where AutoPkg, it opened it up to me in my workplace. I could use the command line, but my coworkers didn't know how to do that stuff. So I was able to train my team on AutoPkg, and I managed it with AutoPkg itself to do some of those more technical configurations. That new role that I was just mentioning, it was in our central IT. I was being asked to stand up a multi-tenant MDM that was new, something that could be used by the entire university. And to me, AutoPkg was a tool for the job. Excuse me. It enabled me to very quickly build out and maintain, which is the important part, a very large software catalog that the entire university could use. Today, we all know that that's easy, that's super possible, but back then that was super novel concept. All right, moving forward. We continue to get some steady updates with some new features and stuff, but it's not until 2016 that we got a 1.0. By this point, though, most of the functionality that we know and love today had been added. With AutoPkg run, search, repo add, and update, even the verify and update trust info are in there at this point. But also, AutoPkg news is everywhere. If you went to a conference, you were guaranteed to be bombarded with a session about AutoPkg. This year, there's 4. In 2016, there were 4. 2017, there were 4 in this conference. It was absolutely inescapable at the time. And to that end, I wanted to pause here for a second, because up until this point, most of the development work was done by Per Olofsson, Greg Nagel, and Tim Sutton, which I believe deserve an absolutely huge round of applause for this. Yeah, okay. One of these 3 is in attendance with us today. I don't want to call him out, but he's pretty recognizable. These guys did leave they laid the groundwork for everything that followed with this, which is a huge, groundbreaking thing, right? It was a low-code solution that was, solved real problems. 15 years later, it's still in use. So, I think that alone, is enough that this deserves a celebration. And like I said, I wanted to do a song and dance. I don't have the voice to do it, so if anybody else wants to do a song and dance, I didn't take here. I am going to go back in time a little bit, because in late 2015, we got a new GUI tool, Recipe Robot. It was developed by Elliot Jordan to make it easier to create AutoPkg recipes, as the name it assumes. But it also served as a learning tool for a lot of people. It showed a lot of new people what a well-crafted recipe should look like. So it helped provide a lot of context for people. And just like AutoPkg did for adoption, Recipe Robot opened those floodgates for new recipes. And as you might imagine, that number grew astronomically. No longer was AutoPkg just for the popular software that a few people used, or that everybody used, I should say. More and more of those niche software titles had ready-to-use recipes that somebody could just grab and use. And if you found one that was missing, Recipe Robot was your tool to be able to create a new one. Elliot states today, or that as of today, over 20% of the recipes that are in the AutoPkg organization were created with the help of Recipe Robot. All right. So in 2017, I feel like the landscape was starting to change. People were starting to look to automate the automation tool. By this time, AutoPkg had gotten pretty mature. It wasn't changing a whole lot. So I personally think this is a pretty normal progression of tools like that. A couple of Facebook employees at the time, Nick McSpadden and Nate Walk, for sure. There may have been some others, I don't know. They released a wrapper script that they named autopackagedtools.py. This created a separate Git branch and created a commit for every new item that was imported in the Monkey repo during an AutoPkg run. This was just a Python script that you could run that did all this stuff. That was released 8 years ago, and in that time, this script has been forked and modified and forked and modified and forked and modified. It's countless. But around this time, we had some other enterprising Mac admins starting to work to run AutoPkg as part of CI/CD pipelines. This blog post from Rick Heil is not the first, but I feel like it seemed to reignite that initiative from a lot of people. This process used AutoPkg tools under the hood, and he obviously used GitLab CI as part of it as well. I don't think GitHub had GitHub Actions yet at this time. And Rick is saying no. I never confirmed that, but I thought that. Moving into 2018, we got a blog post from Tim Grabin, I think is how you pronounce it. You guys probably know him as TIG, which also centered around GitLab CI, obviously because GitHub couldn't do it. But of course, neither of those posts were the first. That award goes to Steve Wood, all the way back in 2013. Unfortunately, I don't think Jenkins ever really made it mainstream, so that's kind of why I put it here. But it's still an important part of the history because it kind of got some other people thinking. And a couple years later, it kind of took off. But also in 2018, actually, hold on, let me get a drink. Due to some changes in Mac OS and some SSL issues with the OS, AutoPkg is pushing people to, kind of need the new operating systems and things like that. While at the same time, AutoPkg hadn't really gotten some updates. It was struggling. So a lot of people, a lot of the community members were starting to look to move past that. But it did have some features that some people wanted to take with them. This is when Graham Pugh released the Slacker post-processor, which I think has been pretty instrumental as well. It allowed admins to easily send Slack notifications as part of the AutoPkg run, which didn't need AutoPkg, it didn't need a Python wrapper, it just worked. Soon after that, Rich Troughton released AutoPkg Conductor. This tool was essentially a bash script, if I'm not mistaken. But he also provided some sample launch daemons and things like that to help put it in place. It made it easier for admins to schedule the runs even when nobody was signed into the computer, which was a downside to AutoPkg at the time, is that you had to have somebody logged in at the time. He later added Teams as well. And this used that Slacker post-processor. And if I'm not mistaken, I think that Slacker post-processor kind of jogged his interest in doing it. But I don't want to put words in his mouth. The novel thing here was that you could do this stuff just from the command line. Like I said, you didn't need AutoPkg, you didn't need a Python wrap or anything like that. So here we're going to skip ahead of 2020 a little bit. But at this point, we're faced with the end of Python 2. And I know I'm sorry for cursing. So, additionally, William Thieker and Harry Sieber from Gusto made a new fork of that AutoPkg tools script. I think they forked TIG's fork of the script, but they also included some GitHub Actions examples. And this is where the GitHub side starts to take off. And personally, I think this project set a new standard for what people are doing in CI/CD pipelines today, still. I found quite a few cases of organizations and just people in general posting about their workflows. And when I look at them, they're all derivatives of this Gusto version. In 2021, AutoPkg 2.3 was released. This brought YAML functionality. It's hard for me to believe that it's been 4 years since that came to be and that we still don't have much YAML. I'm personally hoping that YAML becomes the default one day. Until then, I'm keeping my fingers crossed on it. Since then, we've only really gotten some minor changes, some minor bug fixes, some things like that. We've had a couple of releases for them, but that's about it until today. AutoPkg is a tool that has saved me hundreds, maybe thousands of hours, just me, in this room. That's guaranteed to be in the tens or hundreds of thousands of hours of time that this tool has saved us. A lot of care and feeding has gone into that project to keep it running for so long. So, if you are one of these 51 contributors, you have my thanks, heartfelt thanks. Please take 2 pats on the back from the Petty Cash Fund for your efforts. You have my permission to do so. Now, seriously, though, I do want to thank you. It's been a great tool for a lot of people for a lot of reasons. That same thing, by the way, goes to anything that is AutoPkg related, right? The tools that I've listed, tools that I didn't list, things like that. If I named you earlier, thank you. If I didn't name you, thank you. That ecosystem thrives as more people contribute to it. And to that end, that's where this tool that I wrote comes into play. There have been many projects that I didn't list here. And time will tell if this should be on the list. But it's my presentation and it's my tool, so I'm putting it on there. I get to do that. So a little bit of backstory on this. I've been working out in my head trying to figure out how to deal with situations where, especially in CI runners, where the AutoPkg cache does not persist between runs. In those situations, you have to download those packages every single time you run AutoPkg. If you've got a large number of recipes, that can take some time. It's a lot of wasted effort. And there has to be a better way. I just kept thinking that to myself. It's been years now. So I kind of did a POC at the end of the year for my job. And this wasn't a requirement for it, but I kind of wanted to crack that and wanted to do it. And I thought that I had it. And then I got pulled off of that project. And so I didn't get a chance to really confirm that my suspicions were right, confirm that the workflow that I had come up with was going to work, and that it wasn't just the 3 recipes that I had been running in tests and that stuff at that time. But like I said, I got pulled off of that project at work, so I didn't get a time to deal with it. So of course, it rattled around in my brain for months. So what I basically decided to do was take that and put it towards a community project. So this tool is something that was purpose-built for distribution for everybody to use. It's not something that I use for my company that I generalized and made it available. It was purpose-built for this that we can use within the company as well. So I set some goals for myself in that process. Obviously, the main goal I wanted to do is I wanted to make it easier for CI/CD workflows by storing the metadata somehow for every file that gets downloaded. I also wanted to keep the storage costs low, and so I didn't want to use the full files. So I wanted to use that data to reconstitute the cache on subsequent runs. I also wanted to make it super easy to use. I think that that's important for adoption. It's important for support, lots of things. I didn't want to have to define new AutoPkg preferences. A lot of you guys already have that stuff. I wanted to keep it, keep that learning curve as low as possible. And I wanted to define some sane defaults. I wanted things to be, so you wouldn't have to define all of the different parameters if you didn't need to. I wanted those to be good enough for most people. I wanted it to be fast. AutoPkg does basically everything sequentially. And I felt there was room for improvement just by adding some concurrency to the tool, adding some multi-threading where needed. And then lastly, for the developers in the room, there's a lot of consternation about Python and its typing and things like that. So I wanted strict typing like Swift does. I had planned to use Python, which is capable of doing that. You just have to set up your environment to do so. To me, type annotations are not required in Python, but they should be. They make the code more reliable, more readable, more maintainable. They don't do anything for performance though, so it's just for developers. It's just for people it makes it easier to work in the code base. It makes it easier for you to contribute things back. Makes it easier for you to understand what it's doing so that you can report that to your teams and train things and things like that. Make it easier for you to extend the capabilities if you need to. So I wrote the tool. And this is sort of what I came up with. These are kind of the features set for it. I decided that in order to make it easy to use, I'd set it up so that it could be run as a Python import. You can interact with things just like any other import. But it can also be run as a command line binary. However, that most compelling feature is the metadata caching. And it works brilliantly, if you ask me. Now, of course, since I wrote it in Python, I believe that I am contractually obligated to show this, at least this portion of this XKCD. I'm not entirely sure, so I did it just to cover my bases. All right. I was successful in making the recipes run concurrently as well. So the faster your internet connection, the bigger the difference in runtime versus the native AutoPkg. And then lastly, even though the name implies it, while this can be used in the cloud, it does not have to be. You will see speed improvements regardless, and that's because of the concurrency of it. So getting into the installation a little bit, since it's a normal Python library, you can install it with pip just like any other Python dependency. That said, I'm here to tell you, please don't do that. Use UV instead. If you've never heard of it, it is great. Make sure you read about it tonight. I think it's superior to pip and some of the other older tools in every way. You also have my blessing to go convert your projects. Technically, you could also install it with Poetry, but again, seriously, just use UV. It's better. All right. Sorry for that sidetrack. The default cache storage for the metadata is a JSON file. It just gets put in the same repository that you're running from. You can configure that or whatever, but that's the default. If you want to be explicit about it, you can install that as an optional dependency, but all of the dependencies are already included for JSON. There are other options though. You can do SQLite. You can store the metadata in an Azure container. You can store it in Google Cloud Storage. And lastly, you can store it in an S3 bucket. For those of you that don't know this, formatting this is installing the tool with some optional dependencies. Since there's multiple different mechanisms, I didn't want to add all of the dependencies for every install. So you get to pick what you need. So adding this bit to it makes sure that the dependencies are necessary, that the necessary dependencies are installed. You still have to configure it to use that plugin though. I'll come back to that in a sec. If you want to run it as a command line tool, the easiest thing to do is do uv tool install. This command will create it as a legit binary on your machine. It's also super easy to upgrade, uv tool upgrade. So the cool thing is that uv handles all of the dependencies that it needs as well. So it will make sure all of that stuff is maintained every time you need it. You do still have to specify those optional dependencies even when you do it with uv tool upgrade or install. Before I move on, I should ask, does anybody have any questions so far? Let's stop there. I'll take a break and get a drink. No? All right. Luckily, my voice is kind of holding on. Okay. We're doing good on time, too. So let's switch gears to usage. If you use the uv add command, then you have to use uv run when you want to run it. But if you use the uv tool install, like I suggested, it's just a binary. You run it just like any other binary on your machine. Obviously, I think that's why that uv tool install is the better approach. So let's get into some of the parameters. You just saw recipe. These 4 can be set multiple times. So you can do -- recipe Firefox, -- recipe Chrome, and yada yada. You can do multiple preprocessors, multiple post-processors. You can do one or the other, whatever you need. Let's see. The recipes will not necessarily be run in the same order that you give them because they're running concurrently, but the pre and post processors definitely are. So if you define them, that is the order that they'll be run in, because that matters. I should also mention that all of the parameters in this tool are optional, but obviously if you don't specify a recipe, it's not going to do much. So the reason that it is optional is because you could do recipe list as well and just give it a file full of names. But if you don't give it any recipes, it doesn't do anything. These are a couple more command lines, your command line arguments. These 3 are going to be fairly common. Again, they're not required. The cache plugin is where you define things like JSON, SQLite, Azure S3, Google. This is where you configure it to use that mechanism for storing that metadata. These aren't all of the parameters. Everything else is listed in that wiki that is linked above. The cache file is the path to the file you want to store it. If you're using the cloud storage, this is the path within the cloud bucket as well. So it kind of serves both. And then obviously the container name is the bucket itself or container, depending on your tool of choice. If you're defining one of the cloud storage mechanisms, this tool downloads it automatically from that storage, modifies the cache as it needs to, and then re-uploads it. So that simplifies that whole process. So if you guys are storing these tools or this file, because it's one file full metadata, that part of it's kind of taken care of, or should be. If you're doing it as a Python import and my mechanism isn't working for you, you can do it yourself. As I mentioned, that Python import is just like any other import in Python. If you know Python, you know this formatting. You're just importing a library. The catch, though, is my goal was that the command line usage should cover most cases. But, of course, not everybody fits in those broad spectrum things. Some people need to do some customized workflows. Some of them are pretty intricate. I tried to document the code really well so that anybody can use it this way, but obviously it does require a little bit of Python knowledge to do so. And I don't want to get into too much detail on this mechanism because there's way too much to go over. But I'll say there is an example in the wiki, and I'm happy to talk about your ideas on what you might want to do with Python import after the session. So just find me somewhere at the conference, find me on Slack, I'm happy to talk. Okay, so I've talked a lot. So let's get into the demo a little bit. And I'm going to apologize a little bit for this being small. It's not as bad as I thought. I did also lie a little bit. This is just a normal AutoPkg run. I wanted to do a little bit of level setting. I wanted to show what this takes on my machine so you can see the comparison. So I'm running this on a MacBook Pro. This recording was taken after everyone else in my house had gone to bed. I have a 1 gig fiber connection, but I was on Wi-Fi. So keep these things in mind so you can kind of compare that to what you're going to be doing. This is going to take a little bit, so let's talk a little bit about what you're seeing on the screen here. This is the contents of that recipe list.txt file that I call it with. It's got a total of 13 recipes in it. If you can't read that, we've got one password. There's a couple browsers, Chrome and Firefox, the Office apps like Word, Excel, PowerPoint, etc., Teams, Slack, Octaverify, the Unarchiver. So 13 recipes. They're all monkey recipes. I did this for simplicity. They don't have to be. But you can see the repo is over here as well, so you can kind of see it working as it's going. The AutoPkg cache is also populating as it goes. This is happening as the recipe starts, not necessarily as it's completed. And then up in here, you can see that cache climbing slowly. For these 13 recipes, this cache is a little over 6.5 gigs. So, we have a little bit of time, which I guess speaking of, I forgot I made this slide as well. I made sure to run this with the time binary so that we actually had output on the screen of how long this takes, because it feels like forever. This recording also is in real time. I didn't want to speed it up. I wanted you guys to feel just what this takes. This is only 13 recipes. Most of us have automated this. We don't see it day to day. So it's, what, 2.3 gigs? Man. All right. I should probably ask some of this stuff beforehand, but I got a little bit of time to kill, so I'm going to ask. Is anybody in here not using AutoPkg? Okay, there's a couple more than I thought. So hopefully this tool makes it a little easier for you guys to use it if you want. If not, I'm happy to talk through some of that stuff. For the rest of you, how many recipes are you guys running? Anybody? 30? 30 or 40? Okay. Anyone else? 20 or so? 120? Okay. You said 60? So I've got 80. Rich says 45. So,
Actually, I got thinking 30 or 40 products, but some of those are 2 recipes because there's a stupid Intel one and an Apple.
Yep. So for the recording, some of them are multiples for Intel and Apple Silicon. I think we've got 80 for the record. Not entirely sure. Yeah, my my workflow is a little weird, though. It takes like 2.5 hours to complete, so this stuff I'm hoping to help us a lot. What are we up to here? We're getting close.
I was running like 4 separate ones just for Cisco Secure Client for various
4 recipes for one product is wild.
It's 5 now.
5 now. Okay. So if you could run your, let me say, how often do you guys run them? Once a day? Once a day? That's, I think, what people, once an hour?
Yeah.
Okay. So I think most people are once a day. That's just the vibe that I've gotten over the years. If you could run them faster, would you? No? Yeah? I'm getting some mixed results here. I think I would, maybe at least 2 or 3 times a day. I'm not entirely sure if we would or not, but I don't know. Okay, this is almost done. There we go. Okay. So at this point, all 13 of those successfully imported into Monkey. Can you believe that only took 4 minutes and 50 seconds? That felt like forever, didn't it? Right? I don't know if that's easy for you guys to see or if my head's in the way. 4 minutes, 50 seconds. When you're waiting on something, it takes forever. So yeah. So let's take a look at the output a little bit. So if we scroll down, we can see the installers were all stored in Monkey, as expected. Let's do our thing. Come on. Okay. And then if we go down a little bit more, we can see the report.plist, because I ran it with that command. You can see that structured outputs right here. So if you're doing anything extra, you'd have to parse this, and it can be a mess. But now that it's done, we can use make catalogs to kind of fix up the Monkey directory just to prevent some duplicate imports when we run this again, which also should help keep the comparisons cleaner. So let's clear the screen and let's run AutoPkg again. Now keep in mind that we just ran this. The cache is full. You'll notice that where is it? There it is. That's fluctuating a little bit. It's very unlikely that in the last, minute, that any of those packages were updated, in that time frame. And yet, did I mess that up? I did. Crap. I hit the wrong button. So it's starting again. So I think the main reason is, each recipe determines how it figures out if there's an update or not. There's some different mechanisms. Some of them take a little bit longer. Some are a little more labor intensive. Some of them need to, yeah, we don't want that yet. All right. The cool thing is it's now done. All right. I'm sorry about all that. I messed up my transitions here. Some of those recipes need to unpack the package to check the version and some things like that. So, there are time savings that we can do. I lost the output here again, but 1Password for some reason just failed. Yes.
With regards to time savings, one thing that I previously observed, we were hosting our AutoPkg instances at the
Thank you. Nice catch.
Thank you. Hello? Is this working?
Yep.
Okay. With regards to time savings, one thing that I observed at my previous gig, we were running AutoPkg on AWS hosted Mac Minis, EC2. We had been running them on Intel. So the Intel Mac Minis, we had about 40, 45 recipes, and they were running every hour. And we were noticing that it took about 45 minutes to run the whole list. When we switched to Apple Silicon Minis, dropped in half. So
Yeah.
for folks that are like I want to speed this up, I would encourage you to shift your AutoPkg instance to running on Apple Silicon.
Thank you. Good call out. one of the things I was getting ready to say is that, one password failed for some reason. I don't even know why. It ran perfectly fine the first time. It failed the second, right? But that sort of highlights why we don't want to do this reprocessing if we don't have to, right? We know that worked. So I'm going to skip this ahead to the end again, maybe. I know the box is gone, but maybe. Come on. I messed up this transition. So anyway, it took 1 minute 33 seconds for the record. It was on the screen for a brief second. Check your recordings. That's definitely better than the 5 minutes that it took the first time. And that does highlight how good AutoPkg is already just at preventing redownloads, but it does take some time to figure that out. Unfortunately, though, not everybody is running where the cache persists. And that's where this called AutoPkg Runner comes in. It's where it excels the most. Let's see if I can fix this. Where am I? Okay. I want to make sure I didn't get ahead of myself. So we're good now. Okay. Sorry about that. So at this point, I've reset the environment. The AutoPkg ones are done. The native stuff's done. But I'm going to show you both of those situations, one where you do have the cache and one where you don't. You'll notice that everything is cleared out from that last run, and that we're running Cloud AutoPkg Runner, which is a big mouthful and it's a terrible name. It's running in CLI mode here. This time, things start off quite a bit faster. Since the recipe list is running concurrently, the cache directories are created as it started, like I mentioned, not necessarily as they finish, so it just starts a whole bunch of them right off the top. You'll see that this tool creates a different report file for each different recipe instead of combining it all into one, which I think can make it a little easier to process. They're also date stamped, so they don't get overridden every single time. I also want to take this opportunity to point out that this recipe list is a JSON file and not just a flat text file like AutoPkg accepts. The list, however, is the same for this run. So it's the same 13 recipes. The limiting factor here is my Wi-Fi bandwidth at home. But you'll note that the cache directory is trending up much, much faster. We don't have to wait for things like code sign, verifier, package creator, things like that. The next recipe is already downloading when the first one is completed. So it also will create secondary threads for some of the blocking functions. And for those of you who don't know what that is, it's things like reading and writing from disk, and there's some other things like that. So this tool doesn't have to wait. The main thread doesn't have to wait for it to write one file to write the next, to write the next. It can do all those concurrently as well. In my opinion, the coolest part of the project is that as each recipe completes, it stores that metadata from each download, such as the last modified date, the e-tag, the file size, that type of thing, for every single file that gets downloaded. So if you have a recipe that does need 2 files, it will store the cache for both. And then at the end of the run, all of that stuff is written to disk, since I'm using the default JSON cache here. But like I said, if you're using S3, Azure, Google, those things are written to that bucket and uploaded automatically. So the total runtime for this, with no cache, first run, was 2 minutes 4 seconds. So even without anything else, it's faster, right? Again, the native one was almost 5. It's 4 minutes 50 seconds. So again, this is without any caching functionalities, anything, whatever. It didn't even have the metadata cache to work off of. This is the very first run. I did want to apologize. I forgot to increase the verbosity of this command. I'm one of those believers that if you're writing a tool that should be automated, it shouldn't have any output unless there's a problem, or unless you want it to be. So if you don't give it a -v, there is no output unless there's an error. So that increases with more V's. And if I would have done that, we could see a little bit more of what's going on, but I forgot. Just like before, all of the 13 recipes were successfully imported into Monkey. And as I mentioned earlier, each report is separated into separate files for easier parsing. We'll kind of see that here. And here's the contents of one of them, I guess. It's the same. This is just the native AutoPkg report plist functionality. It's just creating a different file for each recipe. All right, so here's the contents of that metadata cache file that gets created as part of this tool. This is not native AutoPkg stuff, but I figure that's probably hard to see. So here's a snippet for one recipe from that file. This is the Google Chrome recipe. You can see that it's named by the recipe. The key for it is the recipe. So it's easy to find. It has a timestamp from when it wrote the data last. And then it includes the metadata as a list for each file that's created, and each one of those has these 4 fields at the moment. If the cache file doesn't exist, the tool will create it. Otherwise, if it sees one, it'll use it, it will modify it, and it'll append the changes to it. So we don't have to manually create the file if it doesn't already exist. And that is actually how if there's an issue for whatever reason, you might need to modify that cache, delete this Google Chrome key so that it can do its thing again. So on the next run, this cache file is then used to populate that AutoPkg cache. It does so with fake dummy files, stub files, if the files are not already present. So if they are, it doesn't do anything. So if your cache exists, it's just using those cache files. If it doesn't already exist, it'll create some stub files for you. So let's get back into the demo. Just like last time, we're going to run make catalogs again. Okay, it's going. Again, this is to prevent the duplicate imports. We're going to clear the screen, and then we can run the same command again. And I'm just going to wait. Because it's already done. This took 8.4 seconds to complete. Again, this has full cache. But the comparison here is this took 1.5 minutes with native AutoPkg. Like I said, the cache is still intact, so that's sort of expected. That's kind of the purpose of the tool. So let's see what happens when that cache doesn't already exist. So here I've emptied out that cache directory, and we're going to run it again using the metadata cache.json file for its cache this time around. And I'm going to wait because it's done already. This one, it took 8.5 seconds, which is a little longer, but I mean, who cares? All right. So I want to take a little bit of a closer look at that cache directory, because you'll notice it does say that it's 6.5 gigs. But if you look a little closer, it says that it's only 348 kilobytes on disk, because that's all it actually wrote. So it faked the file size of all these files, because that's one of the things AutoPkg uses to determine if it needs a new file. So it's writing fake enough files that AutoPkg thinks that the cache exists. Obviously I ran this a second time right after, so there was no updates. But if there were an update, it would overwrite this stub file, obviously, and then you'd have a real file in its place. And behind the scenes, this runner runs AutoPkg with an underdocumented -- check command, which just does a partial run. If it detects changes, it then runs the full run. So it would do it at that time. And then in the cache, you'd see a little more data in here. All right. Let's see, where was I? Okay. I just wanted to compare this to the native one. So the one on the left is that native AutoPkg run. The amount on disk matches what's in the top of it as well. Please don't ask me why these values are different. I honestly don't know. I'm chalking it up to just APFS things, but I honestly don't know because they were run 20 minutes apart, something like that. While we're comparing things, I wanted to kind of highlight the recipe list. I mentioned it earlier, but I wanted to sort of highlight this. CloudFront AutoPkg runner requires that recipe list to be valid JSON. AutoPkg is just expecting a text file with a list of the recipes. But another thing worth noting here is that the partial matching works just like it does with AutoPkg. So in here you can see msxl.monkey and the unarchiver.monkey. They don't have the .recipe at the end, so it's doing some searching and finding and matching on the recipe name just like you'd expect. Also, the Firefox recipe in here is a YAML recipe. And I did that to kind of show that you can intermix the different recipes. It all works. But I can hear your thoughts. There's no CI demo. I figured I'd tempt the demo gods with this a little bit and do this one live because I'm not actually downloading 6.5 gigs to my laptop 4 times. So let's see here. One of the things I didn't necessarily call out is that the project itself is Cloud AutoPkg runner within my GitHub, but I also have another repository that is the hope of it is to kind of show some workflows and some things like that. Right now, there's only one because I haven't had the time to kind of build it out, and there's not been a whole lot of adoption yet. So I'm sort of hoping to get some help with that as well. As people implement this, we can build this out into some other ways of doing it, right? I want to kind of breeze through this a little bit and show, it's setting up and pointing to, it's caching this metadata file. So between runs, my file gets cached within, the GitHub Actions. We do a little bit of setup and some installs for AutoPkg and Monkey. We configure AutoPkg. This is something I want to make better. Oh no. Thank you. Let's do this. Will this work? No. Man. All right. So let me start that over real quick. Right in here, this is where it's defining, that metadata cache is what gets, it's cached between runs. So every time this action runs, it'll store this file. This is why the default JSON thing can work without even needing cloud storage. We configure some Git, do some installs. This is what I was saying I want to make better. I'd like to be able to inject that better. And then we do a run AutoPkg command. So this is just the definition of a GitHub workflow. And then these two are 2 runs that I actually ran a few days ago. You'll notice that the total time is 3.5 and 1 minute. I'll dig into each of these a little bit. This one ran with no cache, no metadata cache, nothing. It's the very first run essentially. So in here you can kind of see the steps that everything took, right? We set up that cache, we installed AutoPkg monkey. The run command, I'd used 1v in here. I probably should have used 2 to give a little more information. But you can see that with 1 level of verbosity, you start seeing warnings. And this is a warning because the cache file didn't already exist, which might be something that you were expecting. So it's a warning and not just info. It didn't do anything else though, but it ran in 2 minutes 48 seconds to do that full run on a hosted Mac OS GitHub runner. 6.5 gigs of data. 13 recipes is a little small for most of what you're seeing. So like, you guys could probably expect this to run in about 5 minutes for most of your environments. And again, this is without any caching data whatsoever. If we want to see that, the second run took 1 minute in total to complete, but most of that was installing AutoPkg and installing monkey. Installing monkey, not AutoPkg. Okay, in here you'll notice that the warning, it doesn't exist because it used the JSON file that was cached from the previous run. And it only took 20 seconds this time to run the whole thing. Is there any questions about any of this? Perfect. All right. Let me go back to this and see if I can't, and see if this is going to work. It is not. Ooh. Haha. Oh no. That is not what I need. Let me fix this. All right. Okay. So let's get into some of the takeaways here. I hear a lot of people say that, speed is a nice to have, and largely it is. A lot of people say it's no big deal if it takes a while. I am here to tell you that it matters more than you think. That 5 minutes seemed like forever as an example. If you have to wait 30, 60, 90 minutes for your run to complete, that can take you out of your flow. Even 5 minutes can take you out of what you're trying to do. Or maybe you switch and go back to doing something else and you forget what you were doing and you come back to this 2 hours later and go, oh yeah, I was troubleshooting something. It can make debugging super tedious when it takes a while. And it can limit how often you check for updates, right? You said you're running yours every hour.
Yes,
If you could run it more often, would you?
probably not.
I didn't figure, but I wanted to know.
It takes me that long to log in to this system.
It does not take you an hour to log in.
Somebody else set that up.
The takeaway, though, is that the faster your scripts run, you're also less likely to hit those, transient network things and stuff like that, right? Like, it matters. So if it can run faster, you're less likely to have issues. But there's also some financial reasons. GitHub Actions are billed by the minute. But also, the freedom to throw away your AutoPkg cache after every run can lower your storage fees and stuff like that as well. And, it might not seem like much, but that stuff can add up. So let's talk a little bit about what's next. I want to support the URL downloader Python mechanisms. That processor stores its metadata a little differently, and I have not yet built that out because it has some backwards compatibility to do it the same way that URL downloader does. The problem is it's not cross-platform compatible, so you can't do those on, say, Linux. So I definitely want to make that better. I want to make this more cross-platform compatible than AutoPkg is today. I want to do some integration testing. Right now, there's no tests to make sure that the files are actually being properly uploaded to those cloud storage things. At the moment, I don't even know how to do that. I haven't spent any time on it. It's something I know needs to be done. We got a ton of unit tests in here, but there's no integration testing. So that is something that, if you guys have any experience with, please reach out to me. I will look into it eventually, but today's not that day. And then lastly, I called this out, but I want to do some configuration file support. I want to be able to interject AutoPkg preferences. Right now, we're just reading them. So that's why that GitHub action does a bunch of defaults writes, because it has to be in AutoPkg before my tool can read it. I want to be able to interject that. I'm personally thinking that, like a TOML file or something with both, different sections for the different tools. I'm really not sure. But those are kind of three things that I think are on the short list of improvements that we're going to make to this. I am open to suggestions. There's definitely use cases that I haven't thought of that you guys are going to run into that I'm going to go, that's really cool, we should do that. So looking for feedback and stuff like that is definitely awesome. So to kind of finish things out a little bit, if you're interested in any of the projects that I've mentioned, I've got, I think, all of them listed up here. There's quite a bit, and I'm sure they're hard to read. Snap a picture if you want, but like I said, the slides are online. Yeah. Does anybody have any questions? Who's got the box? Okay.
So it looks like you're storing files to the cloud services. Have you thought about any key value storage or different?
I thought about it, but I actually I didn't figure that there was much need for it. I wasn't sure how useful that would be. It's definitely, so those storage mechanisms are just a plugin.
Mm-hmm.
So it's just adding another file with the feature set and, adding the ability to configure it. So it shouldn't be hard to add if that's something that people are actually using or wanting. So I considered it a little bit, but I hadn't prioritized it.
And then I saw you were running 3.13 for Python. Were you installing that or using that from the CI runner for GitHub?
So that version comes from
UV?
It came from UV.
Okay.
I have, this tool is specified as 3.10 or newer,
Okay.
because that is what AutoPkg today is running. So I will say that the unit tests are run on Python 3.10, 11, 12, 13, and even 14, even though it's not out yet. And it runs those all on Windows, Linux, and Mac OS runners. So I'm trying to kind of cover all those bases. The Python gets installed in this example just as because it's, UV is installing it, right? And it's one of those things. That's why it's an important and powerful tool to use. UV just handles that.
And you said you were threading things, so are you doing multiprocessing or threading or async or?
So most of it's async I/O within Python, so there's some, most of it is single threaded and just, multi, coroutines. But there is some threading as well for, the blocking functions, so that we'll spin off another thread to write a file so it can keep going without having to wait. So it does both.
Do you know if anything you have would prevent using free-threaded Python in 3.14 or?
I don't think there's any problem with that, but I actually have no idea. I haven't even looked into that. But I can't imagine.
It's a different install, so.
I don't know.
And then the last one was, it looks like you don't have support for AutoPkg preference for specifying a preference file.
Not yet. That is one of those things that,
That sounded like it might have addressed the one concern you had.
Yeah, that's one of those things that I built this and then had to start working on slides, right? And I didn't want to start making changes while working on the slides at the same time and having to change a bunch of stuff. So that is something that I've recognized as I want to be able to do, using the preferences keyword in AutoPkg. Right now it's just not. happy to accept pull requests if that's a higher priority issue for you. But like, that's on the short list for me as well.
Also, thank you for the ride home last year.
No problem at all. Any other questions?
I just have one left. How many Vs do you need to add to get recipe trust errors?
Probably 2. So right now, AutoPkg is run with 1 less than you give it. So if you give this tool 2 Vs, it will run AutoPkg with 1.
With a 1 V. Okay.
I want to decouple that, and if and when I get around to doing config file stuff, be able to configure them separately. But right now, it's just 1 less.
Okay.
Rich in the back?
Thank you. So I saw that this is, from looking at the repo, it looks like various cloud providers are supported. I saw Azure, I saw Google Cloud, I saw AWS. Which ones specifically have you tested with and verified that this works properly?
S3. I meant to add that to my slides, that I have not tested this with Azure or Google Cloud yet. I have a fairly high confidence that it will work because it's a fairly simple process, but at the same time, I have not verified. And this, again, highlights the need for the integration testing that I want to do. Because it's not something you can just spin up easily. I want to be able to automate that. Anyone else? Okay. I promised I'd show this again. So if anybody wants to grab it now. Yeah, it's in the channel as well. Okay. So then I'll move on. I definitely want to throw to the other 4 AutoPkg sessions that are happening this week. We've got one happening later today, right next door. James Stewart. We got a couple more tomorrow, and then we've got one on Friday. If this stuff interests you, go visit them. Some of them are tangentially related to this stuff. With that, though, I want to say thank you. Make sure that you fill out feedback for this session. Good feedback, bad feedback, I don't care. I'll take it all. I want to improve what I'm doing, and we'll figure it out from there. But also, thank you to you guys up there in the booth. Thank you to Penn State for letting me have here, and thank you all for coming.